Hello everyone. Welcome back to Dr. Lou's VCE Physics channel. Today, let's learn together about the 2023 physics examination. We will focus on questions related to the magnetic force. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. To apply right-hand rule, we find that the magnetic lines direct from the x pole to the y pole. So, x is the north pole and y is the south pole. So, A is correct. Two straight carrying wires, P and Q, are parallel, and the currents are of the same magnitude but opposite in direction. Apply the right-hand rule to determine the direction of the magnetic field induced by the current. Please draw 5 field lines in figure 2b, not 2a. Since the magnetic field is a vector, both lines add to form the resultant vector in the middle. The middle field line is straight and compulsive. Other field lines are circular. The two wires will repel each other. Applying the right-hand slap rule, the direction of the magnetic field is the same. Like fields repelling each other, so the two wires will repel each other. When the current is the same, the directions of the magnetic field are opposite. So, they will attract each other. When the current is opposite, the directions of the magnetic field are the same. So, they will repel each other. Apply an electron gun to measure the ratio of the charge to the mass. Electrons are ejected by an electron gun, accelerated by an electric field, and deflected by a magnetic field. Finally, electrons attain a fluorescent screen. The light pots on the screen show the pathway of electrons. When the electron source produces the electrons, we assume that electrons are at rest and the initial speed is 0. These electrons are accelerated by the electric field between plates A and B. We assume that all electric energy is transformed into kinetic energy. Combining the electric and kinetic energy equation, we solve one electron's final speed. The magnetic force is always perpendicular to the velocity of electrons, so it doesn't do any work on electrons, and the speed of electrons is constant. Since the speed of electrons is constant, the forces on electrons are constant in a uniform magnetic field. Therefore, the path of electrons is circular. Since the path of electrons is uniform circular movement, we combine the centripetal and magnetic forces equation to acquire the equation of charge movement in a uniform magnetic field. Here, the charge is the electronic charge and mass is the electronic mass, so we substitute them with electronic mass and charge. Voltage is varied, so it is the independent variable. Radius is measured, so it is the dependent variable. The strength of the magnetic field is constant, so it is the dependent variable. Calculate the square radii and fill them into the table. This question is well answered. Draw the curve of V0 versus square r. Plot the values of V0 on the y-axis and the square r on the x-axis. A point for 0 must be included. Label the y-axis as volts and the x-axis as square meters. Add the error bar to the x value. Draw a straight line of best fitting. To fit the results, points should be evenly distributed on both sides of the line. The line is not the best fitted measurement if it is forced through the last points. The gradient of the line is the ratio of rise to run. Please note that the units of the gradient are voltage per square meter and the number of significant figures is 1. After a review of the general linear equation and equation in part D, we find that the ratio of charge to mass is hidden in the gradient of the line. Solving the ratio of charge to mass from the gradient, and then substituting the value of variables into this equation, we get the ratio of charge to mass. The units of the value are coulomb per kilogram and the number of significant figures should be 1, not 2. There is one multiple choice question worth 1 mark. There are 2 short answer questions worth 25 marks in the magnetic field. The overall score for this section is 26 points. With a total possible score of 130 points, the percentage for the electric field is 20% of the total score. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel and Lou's VCE Chemistry channel.